for any theta element of pi over 4 comma pi over 2, we are expected to find the value of the following expression. The expression 3 times of sine theta negative cos theta raised to the power of 4 positive 6 times of sine theta positive cos theta raised to the power of 2 positive 4 times sine raised to the power of 6 theta is equal to what? 4 choices. So choice A, is it 13 negative 4 times cos square theta positive 6 sine square theta cos square theta, or is it 13 negative 4 times cos raised to the power of 6 theta, or is it 13 negative 4 times cos square theta positive 6 times cos raised to the power of 4 theta? And D is 13 negative 4 times cos raised to the power of 4 theta positive 2 times sine square theta cos square theta. Now, if you do not have time, there is no time at all, and you are expected to make a choice, which of these would be your selection? Come on, place that in the comment box. Now you should be true to yourself, right? You are given 4 choices, A, B, C, D. You are expected to pick just only one. So which one would you choose? Now, if you don't have time at all, now clearly what you need to do is you have to make an observation. Just see the choices. The first choice has got cos square theta, sin square theta, cos square theta. The choice number C has got cos square theta and cos raised to the power of 4 theta. And then you got cos raised to the power of 4 theta and 2 times sin square theta cos square theta. So A and D are not going to be the selective choices at all, because you can clearly see that A and B are actually one and the same, except for the factored value being different. Now coming to the point B and C. Now if you were to see, all of these terms have got 1, 2, 3, 1, 2, 3, 1, 2, 3. The only term that isn't having the third term is B. So this would be the likely choice. Of course, I'm not asking, or I'm not telling you to resort this way. In the event of not having time, if you don't have time, then you can always adopt what is called as intuition, right? Mathematical intuition, and that is accepted science, right? So that is actually trial and error. The very concept of trial and error is based on what? It is based on your ability to guess and check. So this is actually a branch, guess and check. Of course, we can't be guessing and checking. This will give us a rough idea. So I'm just giving you a tip. So having mentioned this, what I wish to tell you is, in this particular question, though I'm going to give you the exact steps and the algorithm, how exactly we're going to achieve it, clearly I know that there should be cosine involved in the solution. Apart from the guess and check technique which I just mentioned to you, and the mathematical intuition stuff which I've just given you now, there is the other way. The other way is observation. By observation, I know that I should definitely have cos in the solution. So having known that, let's proceed in going step by step and then finally achieving our means. So students, what I will do is I will write the given question, given expression, which is actually 3 times of, I'm not going to use write sine theta as sine theta. I'm going to use the representation as S. That would save us some time. So this is given 3 times. S stands for sine theta and C stands for cos theta. In this case, this is being given raised to the power of 4 positive 6 times of s positive c raised to the power of 2, positive 4 times s raised to the power of 6. This is given. So let us simplify this and find out what exactly this expression is taking us to. So I can rewrite this as 3 times of s negative c. I want to raise this to the power of 2, and then I'll raise this again to the power of 2. Positive 6 times. If I were to expand this, I would get s squared positive c squared positive 2 times s into c, positive 4 times s raised to the power of 6. So this can be further rewritten as 3 times of, I expand this, I get s squared positive c squared negative 2 times s into c. This is raised to the power of 2. Positive 6 times s squared added with c squared. Sine squared added with cos squared will give me 1. Positive 2 times s into c. Positive 4 times of s raised to the power of 6. Now similarly these two can be added. So this is going to give me 3 times of 1 negative 2 times s into c raised to the power of 2, positive 6 times 1 positive 2 times s c, positive 4 times s raised to the power of 6. So this is further rewritten as, I have to expand this, I get 1 positive 4 times s squared c squared negative 4 times s into c, positive 6 times of 1 positive 2 times s into c, positive 4 times s raised to the power of 6. Now this is rewritten as 3 positive 3 times 4 12 s squared c squared negative 3 times 4 12 s into c, positive 6 positive 12 times s into c, positive 4 times s squared negative 12 times sc, positive 12 times sc can be cancelled. 3 added with 6 would give me 9, followed by 12 times s squared c squared. This is actually 4 times s raised to the power of 6, right? So followed by 4 times s raised to the power of 6, right? So now what I wish to do is I would like to split this as follows. So 9 positive 12 times s, the sine square theta is nothing but 1 minus cos square theta, right? So 1 minus c square theta times c square theta, positive 4 times of, now s raised to the power of 6. Now we will have to split this in such a fashion that we are having some level of cos in it, right? Because clearly, as I mentioned to you, we need to have the cos. So I would have to get that. Now the only possibility that we could get it is that we will have to fragment the sine component. So how are we going to fragment it? So what I want to do is I would like to write this as s squared raised to the power of 3, right? It's fair enough. But this is nothing but sine squared. Now sine squared theta is, let me write the formula. Sine squared theta is actually 1 negative cos squared theta. So in this case, I'm going to use s squared is equal to 1 negative c squared, right? So if I were to use that over here, this is going to give me 9 positive 12 times, I'm not going to distribute it as yet, 1 negative c squared of c squared positive 4 times of 1 negative c squared raised to the power of 3. Now this is nothing but a minus b raised to the power of 3, which is nothing but a cubed negative 3 times a squared b positive 3ab squared negative b cubed. So if I were to use this formula over here, this is going to give me 9 positive 12 times 1 negative c squared of c squared positive 4 times of 1 negative 3 times c squared positive 3 times c raised to the power of 4 negative, this one is actually b cubed, so this is actually c raised to the power of 6, right? Because of the fact you got b cubed there. So now let me distribute the quantity. So this is going to be 9 positive 12 times c squared, and negative 12 times c squared times c squared is going to be 12 times c raised to the power of 4, positive 4, negative 12 times c squared, positive 12 times c raised to the power of 4, negative 4 times c raised to the power of 6. C raised to the power of 6 is there. So negative 12 times c squared, positive 12 times c squared can be cancelled. Negative 12 times c raised to the power of 4 and positive 12 times c raised to the power of 4 can be cancelled. We got 9 added with 4, that is going to be 13, followed by negative 4 times c raised to the power of 6, which can be rewritten as 13 negative 4 times cos raised to the power of 6 times theta. So this is the solution that we have obtained. So as I mentioned to you students, this is the complete steps for this question, and we will move on to the next one.